and the y value is 10, and delta y is equal to slope times delta x. So in this case, when 0 and 10, what do you end up with? So you're going to end up, what's the slope? 10. And what's the delta x? So you end up with what? 2? Is that correct? How am I doing so far? Does that look okay? I need help here. It's really easy to make small mistakes. So then, what's the new x value? What's the next x value? 0 point what? 0.2. And what's the new y value, Yana? 12, right. So then how do you get the next delta y? 12 times? It's not 12, is it? What is it? It's the differential is y minus x. So what's it going to be? 12 minus 0.2 times what? 0.2. How am I doing, everybody? Is this good? So what's the new delta y value? Can someone do that on their calculator for me and tell me? Yeah, Yana, what is it? No, not the new. Yeah, so what's the new one? I need the new 2 point what? 6. So then you have 0.4, and then you should have what? 14.36. So do you feel as though you could keep on going here? You're going all the way to 1, correct? So then it tells you how to go about doing this in B. Does the solution to the differential equation appear to be concave up or concave down? When it uses the word appear, that means do not try to integrate this. Don't try to integrate the differential. Like, don't try to find the actual solution. You will run into a wall that you do not have the ability to go over yet. So what they basically want you to do is plot these points and then see, is it concave up? Oh, is it concave up or concave down? Just plot them, right? So when you plot this out, you start at 0, 10, and then you go up to this, and then you go up to this. What is it? I think it's going to be, it looks like it's what? It looks like it's concave up, I think, as far as I remember. In one of the definitions of concavity that we talked about yesterday, or we referenced yesterday, was concave up means the tangent lines are going to be what? Underneath. Like the first one's going to go here, and then it's going to go here, and then it's going to go here, and then it's going to go here. So it looks like it's going to be concave up. So therefore, are the approximates going to be overestimates or underestimates? Which one? Underestimates, right. Is that Sabrina? Yeah, it's going to be underestimates. Does that make sense? The key here, this is really important here, doesn't appear to be. Because you might be driven to try to find the actual differential, and Jan and I were talking about this earlier on this, I think it was this exact one actually. You have dy dx is equal to, what is it, y minus x? Is that a relatively easy thing to write down? Sure. You might then think it's really easy or straightforward, that really terrible phrase, to find a general solution. What did I tell you have to do first if you're going to try to integrate that and find a general solution? What's that first thing? Begins with an S? Separation of variables, right? Look what happens if you try to separate here. You get dy is equal to y minus x times what? Dx. And then you get dy is equal to y dx minus x dx. So you get dy minus y dx is equal to negative x dx. What's the problem there? That's a problem. There's no good way to separate the variables in this. Is this something you can separate? No, you can't separate the variables here, so you don't have the tools right now to differentiate this. You would need to use a computer to find the general solution. So that's why it says, what does it appear to be? There's another one where they don't use appear. Remember the one you did the slope field for? And we were supposed to get the line? So we tried to undo it. You can't. You get stuck. This right here, y'all's got nothing right here. Nothing. You can't do anything right here. Okay, any